All right, here we go, guys. So trapezoids. When you guys were in geometry, we learned how to find area of a trapezoid. Here's the trapezoids that you guys remember. Your trapezoids look like this, where this was base 1, base 2, and you said area of a trapezoid is equal to, let's see, height, base 1, yes please, plus base 2, all this divided by 2. Now our trapezoids are not going to look like this. Well, kind of, but where here's the height. So our trapezoids are going to look like this, guys. Let me draw some random graph. Okay, I'm going to draw some trapezoids.
What is that?
Trapezoids.
But that's not the trapezoid. There's the other end.
Right here. See?
That's a trapezoid.
Yeah, it is. It's a trapezoid.
Why is it missing the other triangle?
Base 1, base 2, height. Just because I don't have this piece of triangle, the definition of a trapezoid is that your bases are parallel to each other and you have a height like that, and that's it. So yeah, that is the same. It's just not a normal trapezoid. That is the same as this, guys. That's a trapezoid. Cool or not cool? You don't like it? Base 1, base 2, and height. You just don't have, it's just not a normal trapezoid, but it's still a trapezoid by definition. Are we still okay, guys? All right. Now, I have a definition here. I have a formula, and I want to know where that comes from. So I'm going to say that this base here is y0, y with a little 0 on it. I'm going to say this is y1, y2, y3, y4, y5. And I'm going to say that this height is just going to be h, and I'm going to call them all h. I'm going to say they're all equivalent. Are we okay so far, guys? So I have, let's see how many trapezoids I have. 1, 2, 3, 4, 5. Do you guys see those 5 trapezoids? So if I wanted to find those trapezoids, I'm going to do this formula one at a time. So area equals, so here we go. So h, and then my first base is y0 plus y1, close it, divided by 2, plus, and then h again, y1 plus y2, close it, divided by 2, plus, does everyone see where I'm getting these numbers from? Yeah. Plus h, y2 plus y3 divided by 2. The y3 is literally this value here, whatever that base is, because my trapezoids are being stacked. Plus h, y3 plus y4, all that divided by 2, plus h, y4 plus y5, all that divided by 2. So get that down real quick. I want you to notice that all of them have an h over 2, h over 2, h over 2, h over 2, h over 2. What can I factor out? H over 2. So if I factor out that h over 2, look what happens. I'm going to write it over here. Area equals h over 2, and then I'm going to have y0 plus y1 plus y1 plus y2 plus y2 plus y3 plus y3 plus y4 plus y4 plus y5. I want you to notice there's 2 of each one except at the endpoints. The very first one that I started and the last one that I stopped. Do you guys notice that, guys? So area equals, in this case, h over 2 y0 plus 2y1 plus 2y2 plus 2y3 plus 2y4 plus y5. And look, there's my formula. the same thing that I just derived, and I want you guys to see. We could very easily have said just use the formula. Come on, my spots get focused. We could easily have said just use the formula, but I want you guys to know that that formula comes from somewhere. How do we feel? All right. So here's a warning, because some of you guys want to force the issue. You can only use this formula when I have equal subdivisions, when all the heights of every trapezoid is the same. Does that make sense to you guys? I cannot use this formula if the heights are not the same. Cool or not cool? Okay, I'm going to say it again. You can only use this formula when the subdivisions, the heights of each trapezoid is the same. Yes. Side note, SN. You can only use this formula when you have equal subdivisions. That the heights are the same. That means, i.e., heights are the same. Now look guys, our heights, isn't that just like a delta x? The way I have it written? So our heights are just like going to be delta x. How do we feel right now, guys? Do we feel okay? All right. Let's see if we can do this. Don't worry. I know you guys are visual. I'm going to show you guys the graph, and I'm going to do all that good stuff. Right, Ms. Conchas? Yes. All right. So example 1. Use the trapezoidal rule with n equals 4. So that means they want me to have 4 what? 4 trapezoids to estimate the area of the curve between 1 and 2 of x squared. So I'm going to exaggerate x squared. So here I am blowing this guy up, and I'm going to exaggerate x squared. There it is, exaggerated. So I can see. I'm going to say 1 is right here. I'm going to say 2 is right there. So how do I find my quote-unquote height? Well, if I have 4 trapezoids, so this distance is 1. So 1 divided by 4 is 1/4. So that's going to be your height, guys. I'm going to say change an x, which happens to be height, which equals 1/4. And I guess I'll even do more details. Let me write it like this. 2 minus 1/4, because of that 4 right there. Upper, lower. There. How do we feel so far? So I'm going to say, boom. No, not that one. I'll go a little further. Boom, boom, boom. 1.25, 1.5, 1.75. I'm going to change my color to blue. At 1, I'm going to put a point at 1 and on the curve. At 1.25, I'm going to put a point and on the curve. I'm going to go down. There it is. Because this curve is strictly increasing, my trapezoid is going to be giving me just a slight over approximation, because if you zoom in, I'm just barely above that. Then I go to 1.5, put a point, connect the dots. Then I go to 1.75, put a point, connect the dots. Then I go to 2, put a point, connect the dots. Are all my heights of this trapezoid the same? Remember, the heights are these guys right in green here. Are they all the same? Can I use the formula? Yeah, so here's what I'm going to say. I'm going to start writing the integral symbol now. The integral from 1 to 2 of x squared dx is approximately, okay, for you BC students, you must put the approximate symbol. For AB, they don't care. But for BC, they do. So you must put the approximate symbol. All right, are we okay so far? Nah, when you're doing the reading for AB, they just tell the AB students, because they haven't done Taylor series and all that. They say the AB, there's no penalty, but if it's a BC exam, there's a penalty. All right, here we go. I'm going to use the formula. My height of each one is 1/4. Yes or no? So what's 1/4 divided by 2? Oh man. Does everyone, I guess I'll write good notes here. Yeah, that 1/8 came from 1/4 divided by 2 from the formula, from this right here. Cool or not cool? And then I'm going to open up parenthesis, and it says my very first initial, my very first value is this one. It's x squared. So I'm going to write 1, and I'm going to square it. And I'm going to go plus, and then I put the number 2 in the front. I'm just using the formula. And inside, it's x squared, so I'm going to put 1.25, and I'm going to square it. Plus 2 times, what am I going to put next? 1.5, and I'm going to square it. Yes. 1/4 divided by 2. No, keep change fit. I'm taking a 1/4 and I'm making it even smaller. No, you're dividing by 2. So anytime you take a number that's between 0 and 1 and divide by 2, it gets smaller. Okay, plus, let's see, 2 times 1.75, and I square it. Does everyone know why I'm squaring it? Because that's how I get the height. And then plus, do I put a 2 in the front again? No. You're just going to write what? 2 squared. Giant parenthesis close. And then I take my calculator and I just calculate this. So there's my calculator up there. And I'm going to first do all the inside stuff first. 1 squared. Come on, buddy. Plus 1.25 squared, plus 2 times. Plus 2 times 1.25, close it squared. Maybe it's faster if you type it into the y equals, maybe not. 2 times 1.5 squared. Plus 2 times 1.75 squared plus 4. Enter, and whatever that is, I'm going to divide by 8. And there it is. So my approximate area is 2.34375. Yes. Yes, this is more precise than the midpoint. Usually the trapezoid is the most precise from all of them. Over approximation or under approximation? Over, just barely, but it's still over. Cool or not cool? All right, let's turn the page. I think I stole this one from an AP exam, or I might have stolen it from the textbook. I don't remember. All right. On the interval -2 to 4, if 3 equal subdivisions are used, what is the trapezoid approximation? All right, before I get started, can I use the trapezoidal formula? Yes, because I have equal subdivision. So my height, which just so happens to be the change in x, is going to be 2. Does everyone know where I got the 2 from? All right, I'm going to put it here for good notes. 4 minus a -2 divided by 3. All right, here we go, guys. I'm going to write it like this. So I'm going to erase that question mark, and I'm going to put the approximate symbol. And I'm going to write 2 divided by 2. I'm just showing that work for now. And I'm going to put open parenthesis. And I'm going to put my first point. It's at -2. So I'm going to write e to the -2 divided by 2 plus 2 times e to the 0 divided by 2 plus 2 times e to the squared divided by 2. Close, and I'm going to slow down because I can tell some of you guys are slow writing. Plus, do I put a 2 in the front? No, this is my last one, so you don't. If you want to put parentheses so you can stay consistent, you can. Let me put parentheses on this guy then. Close the darn thing. And then I'm looking and I don't see my answer anywhere. Relax, it's in there. what do you notice that each one of these terms has? There's a 2 in the bottom on all of them. Can I factor that out? Yes. Remember, look, 2 divided by 2 is 1. So here it is. Factor it out. E to the negative 2 plus 2e to the naught plus 2e squared plus e to the 4. Now let's see if that answer is in there. It is. They just wrote it differently. Where is it at? Yeah. D as in Darren. Darren. I know a Darren. He's a crazy guy. Okay. How do we feel so far, guys? Oh, don't worry. We'll fix that letter D as in Darren. The crazy guy. All right. Here we go. Why what? Example 3. The function f is continuous on the closed interval 1 to 7 and has values that are given in the table below. All right, if you want a visual, guys, it looks something like this. 110.430, way up here, point. 640, not to scale, point. And then, I don't know, 720. So somewhere like right there. So look, here's my trapezoids, not to scale. Not to scale. 1, 2, 3 trapezoids. NTS, so NTS, not to scale. What? Okay. No, we got 3 trapezoids. All right, you guys ready? Are the heights of each of these trapezoids the same? No. So I cannot use my formula. You're going to have to go just with the area of a trapezoid. So area of a trapezoid. So look, here's my height of the first trapezoid. The distance between 1 and 4 is what? So I write 3, parentheses, the first base is this height, and that height is 10. So I write 10, plus the other base is the one at 4, and that height is 30, all divided by 3. The difference between 4 and 1 is 3. Oh, sorry, by 2. Shh. Dummy. I apologize. I don't know why I was thinking that was height. Are we still okay? Okay, where did I lose you, Ms. Schmidt? I'm just using area of a triangle, of a trapezoid. H base 1 plus base 2 divided by 2. Yeah, I can't. All right, here we go. Trapezoid number 2. The height, so what's the difference between 4 and 6? 2, parenthesis, and then I need the base at 4. That one is, no, it's a 30. Plus, oh, okay, you're already giving me the answer. The one at 6 is 40.
Oh,
Are we okay, guys, or no? Divided by 2. Last trapezoid, plus, what's the difference between 6 and 7? 1. My first base is 40, plus the second base is 20, and all this is divided by 2. And that's it. We find this area here. See, 30, 40, so I get 3 times 40 divided by 2, plus these 2's are going to cancel. 4, 5, 6, 7, so I just get 70, plus 4, 5, 6, so I get 60 divided by 2. So let's see if we can do this really quick. 2 goes into 40 20 times. 20 times 3 is 60. 60 plus 70 plus 60 divided by 2 is 30. So let's see, 70 and 30 is 100 plus 60 is 160. So the area, the approximate area is? I just added them up. I just did algebraic. No, that is an approximation still. That still is an approximation. All right. Quick review, guys, because this is what your assignment's going to have today. So this is just for you guys to visualize. It says if a function f of x is strictly increasing from a to b and you do LRAM. So let me draw a function strictly increasing. So here's a strictly increasing function. A to B. And if I do LRAM, I'm just going to do 2 rectangles. Or you can see that that is under approximate, and it says under approximate. If a function f of x is strictly increasing, so let me draw again, strictly increasing. And I'm going to go to A to B again, A to B. Then if I do RRAM, I'm going to say boom, boom, and boom, boom. If I do RRAM, this is an overestimate. Are we still okay? All right. If I have a strictly decreasing function, so let's see, strictly decreasing. Doesn't matter the concavity, but I'm doing concave up. So let me draw a better one. There we go. A, B, and what do they have here? LRAM. If I do an LRAM, blue, overestimate, overestimate. If I do another strictly decreasing, strictly, yeah, better not say that. And this time I'm doing RRAM. It is an underestimate. Do the visuals help? Okay. Okay. We're going to do a real AP question from a real AP exam. It's a free response. I just took out one letter. We probably could have done it, by the way, that one letter, but I don't want to give you guys too much too soon. You guys ready? Okay. All right, future fives. Give me your A game. This is a real question from a real AP exam. If you want to know the year, I believe it's 2006, question 6. 2006, question 6. It might be 2006, form B. We'll figure out which one. All right, so A game real quick, guys. Let's get you guys fives. So let's see what we're looking at. We have time, we have velocity, and we have acceleration. Are we still okay? Bless you, miss. All right, example 4. A car travels on a straight track. Okay, so I'm either moving forward or backwards. During this time interval, or left or right, sorry, left or right. During this time interval between 0 and 60 seconds, the car's velocity v, measured in feet per second, and acceleration a, measured in feet per second, are continuous functions. Okay. The table above shows selected values of these functions. Letter A, using appropriate units, explain the meaning of 30 to 60 v of t dt in terms of the car's motion. All right, let's answer that first. So let's see. This means area under the curve, right? All right, so I were to plot the absolute value of negative 20, negative 30, negative 20, negative 14. Oh, actually not those, just from 30 to 60. Negative 14, negative 10, 0, and 10. So I have feet per second times second. What does that give me? Feet per second times second. That gives me feet. What did I just calculate? Like, what is this? What is the area under the distance? Does that make sense? So this just calculated distance traveled. Calculated distance traveled. All right, let me tell you how you're going to have to write it for full credit. Ready? Bless you. Bless you. For full credit, here's what you're going to have to write. You're going to write 30 to 60 absolute value of v of t tells us the distance traveled. Is this a car? By this car from t equals 30 to t equals 60. Done. That's full credit for the first part. Cool or not cool? Are we okay, guys? Okay. Now let's answer the second part. Oh, in feet, by the way. I was going to lose the points. Look, it says using appropriate units. In feet. Tells us the distance traveled in feet by this car from t equals 30 to t equals 60, period. If you want to put units for the time, that's fine. It's in seconds. How do we feel? All right, here we go. Let's answer the second part. Approximate using what rule? Trapezoidal. Notice 30, 35, that's by 5, 35 to 50, and then 50 to 60. None of these are equal subdivisions, so can I use the formula? No, we're just going to have to do it longhand. So here we go. I'm going to zoom out so we can see. So I'm going to write integral 30 to 60 absolute value of v of t dt is approximately, all right, the height. The height of my first trapezoid. Oh, I guess, how do you determine how many trapezoids you have? Like this, guys. Here's what I do to help me. I have a trapezoid. I have one trapezoid between 30 and 35, so I link them like this. And then I have another trapezoid between 35 and 50, so I link it like this. And then I have one more trapezoid between 50 and 60, so I link it. So how many trapezoids do I have total? 3. So that's what I like to do to help me keep track of how many trapezoids I have. So here we go. I'm going to write the height of the first trapezoid. So I have to take the absolute value of this guy. What's absolute value of negative 14? So I write 14, and then let's see. My base 1 starts at 30. Oh wait, hold on. This is wrong. That's wrong. That's wrong, guys. That's not my height. That's not my base. The height. What's the distance between 30 and 35? 5. So sorry, guys. 5. Parenthesis. My first base. What's absolute value of negative 14? 14 plus, what's absolute value of negative 10? 10. And all this is divided by 2 plus. Am I okay with that first trapezoid? All right. The height of the second trapezoid. What's the distance between 35 and 50? 15. And then open parenthesis. The first base is going to be 10 plus, what's the second base? 0. And all this is divided by 2 plus the next one. What's the distance between 50 and 60? 10. Open parenthesis. The first one is going to be 0 plus the next one's going to be 10. And I'm going to divide this by 2. Okay. It's going to hurt me to say this, but I'm going to say it. If you are super paranoid, like super paranoid that you will add this wrong, I don't remember there's no calculator. If you're super paranoid that you will add this wrong, you can leave it alone and you will get the full credit. You do not have to simplify any work that has numbers already on it, like this. If it's like this, you do not have to simplify it. And that will be full credit. If you're confident with your ability to not get any errors, I would go ahead and solve it. Cool or not cool? All right. Now, whenever you get something like cosine pi, you still got to evaluate cosine pi, but you can leave it in terms of just numbers. Cool or not cool, guys? All right. So what do you guys think? Should we evaluate or should we leave it? All right. Let's evaluate. Now I can put an equal sign on the right-hand side of all this because this is what all this stuff equals. All right. 14 plus 10 is 24. 24 divided by 2 is 12. And 12 times 5 is, I think that's 60, so I'm going to put 60. Plus, 10 divided by 2 is 5. And 15 times 5, 15, 30, 60, 75. Is it 75? Plus, and then 10 divided by 2 is 5 again. 5 times 10 is 50. All right, let's add them all up. 60 and 50 is 110 plus 75, 10, 180, 185? Or 195? 110, 70, 180, 185. And I need units. Feet. How do we feel, guys? All right, we'll look at the rubric in a little bit, guys. I haven't seen this rubric in particular yet. In a little bit, we'll look at it. Letter B. Using appropriate units, explain the meaning between 0 and 30 a of t dt in terms of the car's motion. Find the exact value. Okay, let's think about it, guys. Don't worry, I know we're running out of fuel, but we're doing a car problem. But we'll get there. So this means area under the curve. So let's think about it. feet per second times second. That gives us what? Feet per second squared times second. One of these seconds cancels out. That gives us feet per second. So it gives us velocity, but it doesn't give us the velocity at 30. Don't worry, we're almost done. We're almost done, I promise. It gives us the change in velocity between 0 and 30. Does that make sense? Bless you, bless you, bless you. It's going to give us the change in velocity under the curve. Like the area under the curve is the change in velocity. Yeah, I know. We're not advanced yet. Should we stop here then? Since we're not, or do you want to keep going? Want to keep going? Okay. Let me write it down here, guys, what this gives us. Area under the curve from 0 to 30 of A of t dt will give us the change in velocity from t equals 0 to t equals 30 in feet per second. And I think maybe I threw you guys too much too soon. That is something that you'll get once we start doing more and more. Let's find out what this number is. So do they want me to do, find the exact value of A of t? Do I have enough for the exact value? Yeah, I do. But see, I think I gave you guys too much too soon. Let's see if you remember. BC students, don't answer this. Do you remember? Don't worry, we're almost done. Before I put limits on here, what did I tell you that integral stood for? It stood for, start with letter A. What's antiderivative of acceleration? Okay, there you go. So this means velocity evaluated from 0 to 30. We don't know this stuff yet, good enough, so I think this is just extra. So I'm not going to worry about this right now, guys. If you want to put for good notes, don't worry. You can write v of 30 minus v of 0. You don't know this because we haven't talked about upper minus lower of limits, so I'm not going to talk about it. So I'm going to put exempt for now. Are we okay? Yeah, we'll talk about the cat later. All right. Letter C. Last one, guys. Letter C. Give me your A game. Check it out. Is there a time, t, where the velocity is -5 between 0 and 60? So look at it carefully. Yes, there is. Between what and what? What is that theorem called? IVT. Yeah, intermediate value theorem. So here's what you're going to write. You're going to say yes. And I'm going to write since v of 35 equals -10, and since, where's the other one? V of 50? Since v of 50 equals 0, comma, IVT guarantees v of t equals -5 somewhere between t equals 35. So I'm going to put 35 less than t less than 60, period. Full credit. Yes, since v of 35 equals -10 and since v of 50 equals 0, IVT guarantees v of t equals -5 somewhere between 35 and 60. With it, 50. Okay, 50. I still would have gotten it right if I would have left 60 though. But yeah. Cool or not cool? Do you guys want to see the rubric for this question? No? Alright, let's just look at it real quick, guys. And don't worry, we're already done. I told you what year? 2006? Which ones? Oh, yeah, we can do those. We're not ready for all of them yet, but we can do most of them now. Yeah, that's the one. All right, guys. Here it is. All right, here it is. How many points for letter A? 2. 1 point for explanation, 1 point for the value. Let's see how they wrote it. Integral from 30 to 60 v of t dt is the distance in feet that the car travels from t equals 30 to t equals 60. It's going to sound almost the same all the time. There's no other way you can write it. So it's going to sound the same all the time. Look at the trapezoidal method. Did we get it right? Yeah, there it is. Letter B, we don't have to worry about right now. And look what they wrote for letter C. Yes, since v of 35 is negative 10, v of 50 is 0, the I of t guarantees a t between 35 and 50, so that v of t is negative 5. Perfect. How do we feel? Do we feel okay? All right, guys, we are officially done. And you have one little activity on Delta Math, and that's the only activity we have. Once you're done with that, you can call it a day. So let's go ahead and take care of business, and that's it, guys.